Good afternoon, students. Today I'll discuss the important heterocyclic compound isoquinoline. Here I'll discuss about the structure, resonance, reactivity, aromaticity, synthesis. Isoquinoline can be synthesized by Bissler-Napieralski synthesis, medicinal uses, reaction. Coming to structure, isoquinoline is a structural isomer of quinoline. In quinoline structure, nitrogen heteroatom is present in one position, whereas in isoquinoline, nitrogen is second position. See the structure, benzene and this is pyridine, but nitrogen is second position. That is called as isoquinoline. Okay, coming to unsaturated, here bonds are there, that's why it is unsaturated. sp2 hybridized, aromatic in character, because cyclic structure, cyclic planar structure, delocalized pi electrons because double bond, single bond, double bond, single bond, so delocalized pi electrons. That obeys Huckel's rule because it obeys the formula 4n plus 2. How many pi electrons? 1, 2, 3, 4, 5. 2 into 5, 10 electrons. This is all about the structure. Coming to resonance, I have discussed about the quinoline structure. Nitrogen is present in the one positions and carbon in the second positions. So already nitrogen contains the lone pair. So there is no involvement of lone pair involvement, but because nitrogen and carbon already conjugated, contains bonds. So in case of quinoline, if the nitrogen contains one position, so nitrogen contains the negative charge and next carbon contains the positive charge, whereas in isoquinoline, nitrogen in the second positions, that's why nitrogen contains negative charge and carbon contains, first carbon contains positive charge. Reverse. First position cations and second position nitrogen, where it is present, it is negative charge. Okay. Generally, coming to reactions, when the nucleophilic substitution occurs, generally first position occurs because it contains the positive charge. Okay, next, coming to synthesis. Synthesis of isoquinoline, known as important synthesis known as Bissler-Napieralski synthesis of isoquinoline. Here in Bissler-Napieralski synthesis of isoquinoline, beta-phenyl ethylamide is the starting material. So beta-phenyl ethylamide is react with phosphoryl chloride. Phosphoryl chloride is the commonly we can use and as a catalyst, palladium catalyst, to give the corresponding imine, and then this is cyclized to form 3,4 dihydroisoquinoline. Finally, 3,4 dihydroisoquinoline by heating over palladium on charcoal to form isoquinoline. See, starting from the synthesis, beta-phenyl ethyl amide is the starting material. This is the phenyl, this is ethyl, two molecules of carbon. So first carbon is alpha carbon, this is beta carbon. That's why beta position phenyl group is attached. So beta-phenyl ethyl amide means RCONH2. This is amide. So beta position phenyl ethyl amide. Okay, beta-phenyl ethyl amide can be used, commonly used by phosphoryl chloride. Phosphoryl chloride means POCl3 due to electrophilic aromatic substitution reactions. What will happen? Generally here what will happen? Intramolecular reaction will happen because this intramolecular means outside reaction will happen. So what will happen when the nitrogen which contains the lone pair, when it will react with the carbon, the oxygen heteroatom, it will react with the phosphor. Okay, so what will happen? See the nitrogen. Here see nitrogen after lone pair involvement, the lone pair attack the carbon, nitrogen contain the positive charge, so nitrogen valence is 5, 1, 2, 3, 4, 5. Okay, now we got the same structure and what will happen? Oxygen will be attached, phosphor, so we got POCl2 and one of the chlorine will be removed. Okay, and here is you see carbon nitrogen contain a double bond, that is known as imine. Okay, so beta-phenyl ethyl when react with due to intramolecular reaction of generally we can use the phosphoryl chloride. So what will happen? So we will get a imine like compound and reaction is nothing but nitrogen lone pair will be react carbon, oxygen will be react with the phosphor, so that one of the chlorine molecule will be removed. We get this compound and finally next step, during more stable compound that we call as resonance stabilized, one of the aromatic ring, the pi bond attach the carbon so that there is a carbon will accept a charge of the nitrogen. Okay, now carbon nitrogen which contain the positive charge, it will accept the carbon, so we'll get a cyclic compound. Now see NH, this is NH and PO2 Cl2, PO2 Cl2. Okay, So what will happen? PO2 Cl2, next compound, and this one, and see in this reaction, and HCl will be removed and PO2 Cl also removed, means that is called as a phosphorus chloride. Then what will get? See, after removing this HCl and PO2 Cl, then what will happen? One of the bond will be come at a unsaturated, so we'll get a unsaturated compound. See, then here already we need for isoquinoline 3 and 4% is saturated. We need for unsaturated compound, so we'll go for reduction like a palladium catalyst. So we'll get 3 and 4 compound. This is on reduction to unsaturated, or we'll get a compound known as isoquinoline. So this is the final point, important point, that already I have taken beta aryl ethyl amide is the starting material. Intramolecular reaction happens for getting amine. Amine is nothing but carbon contains double bond. Okay, and their electrophilic aromatic substitution reaction occurs, and phosphoric chloride we can use as a dehydrating agent for getting the 3,4 carbon saturated to form unsaturated. Okay, next one is medicinal uses. There are so many drugs which contain quinoline nucleus. Quinopril, treatment of hypertension. Praziquantel, an anthelmintic drug for parasitic worm infection. Tubocurarine is a neuromuscular blocking agent. Papaverine is an alkaloid used for myocardial infarction or chest pain. And dimethisoquine is a topical anesthetic. And there are several uses also we can use for isoquinoline. Isoquinoline is used in the manufacture of insecticides and solvent for the extraction of resins and terpenes. Okay, these are all about medicinal uses. Coming to reactions, I told you electrophilic substitution reactions of quinoline and isoquinoline occurs in benzene, whereas nucleophilic substitution occurs in pyridine cases. So same electrophilic aromatic substitution occurs in 5th and 8th positions. Then we'll go for nitration, sulfonation and halogenation. So all will be happens in 5th and 5th position and 8th positions. And coming to nucleophilic substitution reactions. Nucleophilic substitution reaction, I told you in case of quinoline, nitrogen is present in the first position. So nitrogen contains negative charge first position, second position positive charge, whereas in isoquinoline nitrogen is present in the second position. So carbon means first position, carbon contains positive charge. So here all the nucleophilic substitution occurs at the first positions. Next, electrophilic substitution reaction in case of nitration, nitro group 5th position and 8th position. So 5 nitro isoquinoline, 8th position 8 nitro isoquinoline. Coming to sulfonation, sulfonic acid is electrophile, first position 5th position. So isoquinoline 5 sulfonic acid, isoquinoline when 8th position, isoquinoline 8 sulfonic acid. Then isoquinoline will go for reduction by different reducing agent. We will do reduction with sodium and ethanol. Then what will happens? Reduction with sodium and ethanol. Then 1, 2, 3, 4 all the carbon atoms will be reduced. So 1, 2, 3, 4 tetrahydroisoquinoline will go for reduction with diethyl aluminum hydride. So what will happen? Here only 1, 2 dihydroisoquinoline. Okay, these are all about reduction. Coming to oxidations, isoquinoline oxidation with the oxidizing agent KMnO4. What happens? Benzene contains 2 carboxylic acids, and pyridine means pyridine contains 2 carboxylic acids. This type of compounds will get. Finally, I'll tell you basic character of isoquinoline. I told you basicity of any heterocyclic compound depends upon first one is the lone pair which contain the heteroatom which contain the lone pair. When react with a base, when react with an acid, the proton which contain or the acid which contain the proton will accept the what? Lone pair, or base can be defined as, according to Lewis theory, base can be defined as lone pair of electron will accept a proton from an acid. So here the lone pair will accept a proton and hydrogen to form isoquinoline hydrochloride. Okay, this is the salt. Then if we compare two compounds like quinoline, why quinoline is less basic than isoquinoline or pyridine? Because quinoline structure contain both benzene and pyridine. So one of those heterocyclic compound pyridine, and we can compare with the quinoline or isoquinoline or pyridine, which one is more basic. So first one is basicity, depends upon first I told. First character is what? And lone pair which accept a proton from an acid to form a salt. Second character is what? Basicity of a molecule is defined by its conjugate acid. Which heterocyclic compound is having more conjugate acid? They are more basic in nature. According to conjugate acid, a pK of pyridine is 5.17, pK of quinoline is 4.85, pK of isoquinoline is 5.46. Then if you compare, isoquinoline is having the conjugate acid is more, that's why more basic in nature, then pyridine, then quinoline. That's why quinoline is less basic than pyridine and isoquinoline. Thank you for watching my video.